In Chapter 8, we're going to talk about the investment decision the firm makes. Remember, equity holders and bond holders put money into the company. The company hopefully makes money, and they pay their bondholders, they pay their equity holders, and they take part of the money or keep part of the money and put it back into the money machine. Now the question we want to answer in Chapter 8 is, should the firm buy a certain machine? Should they build a plant? What should they do with this money that they have? And their goal, remember, is to make this into more money. The math that we're going to use is what you've already seen in Chapters 2 and 3 and 6 and 7. We're going to have a very simple structure to this. We're going to say, in general, a firm pays some amount of money today, they make some big investment, and then over the course of the following years they get some cash flow. And that cash flow might be the same, it might be different in every year, but they're going to get some cash flow for some number of years. And the question is, should they spend the money today to get the cash flow in the future? So let's start that with an example, and I'll use the example that's in the text. Okay, so Vincent and Alex are making this Caspian Sea drink. They have the opportunity to buy some type of mixer. That mixer is going to cost them $1,000. They know if they use this mixer that they'll be able to increase their cash flows, and we'll talk about where these cash flows come from later on, but for now just trust me with they increase the cash flows by $500 every year for 3 years. So the question is, should I spend $1,000 today to get $500 per year for the next 3 years? We did this in Chapter 3 basically. So the math looks like this, and we're going to call this the net present value. Well, I have to spend $1,000 today, plus I know you have a faster way in the financial calculator to do this, but I want you to see step by step. The $500 in a year is worth, well, I need a discount rate. So let's say that discount rate is, we'll start with 12%. We don't know where that comes from yet, but we'll get to that later on. So we just do the math like this: 1.12 squared plus 500 over 1.12 cubed. This is equal to 200.92. So the question is, should you do this project? And what do you think? Well, I'm spending $1,000 today, and let me break this down a little bit more for you. The $1,000 today plus $1,292, that's the value of the future payments, and that's in present value terms. So the question is, would you spend $1,000 to get what you value at $1,200? And the answer is yes. So we're going to have a rule. We're going to have the net present value of every project. If it's greater than 0, we accept the project. In other words, since it's greater than 0, we buy the machine. If the net present value is less than 0, we reject the project. If the net present value is equal to 0, we don't care. Now it's important to understand what's going on behind this. What is the goal of the firm? The goal of the firm is to maximize shareholder wealth, right? Well, I'm trying to do that in this investment decision. I'm trying to maximize shareholder wealth. So I'm taking the $1,000 here, put this in red, taking the $1,000 that the shareholders have entrusted me with, and I spend it to buy a mixer. If I buy that mixer, the mixer generates $500 cash flows over the next 3 years. The value of those $500 cash flows is $1,292. So I'm spending $1,000 to get $1,292. I'm increasing the value of the firm by $200, $200.92. So I want you to think of it this way. The net present value of the project is how the project itself changes the shareholder's wealth. If it's positive, it increases the shareholder's wealth. I want to do it. If it's negative, it decreases the shareholder's wealth. I don't want to do it. If it's zero, well, what I care, it doesn't make any change at all. Okay, let's think about something else here. If K was given to you at 12%, what if K increases? Right, so what if K were 13%? What would happen to this number? It would go down. I know that because if interest rates go up, the present value goes down. Would I still do the project? So here's a problem. In reality, it's difficult to come up with this K and know that this K is a precise number, that I know it's exactly 12. What if I'm wrong? What if K is really 13? Do I still do the project? Well, what if K were really 14? Will I still do the project? Well, the rule is I need this to be greater than 0. So I can say if the net present value is equal to 0, instead of K, I'm going to have IRR. So 1 plus IRR, that's for internal rate of return, 500 over 1 plus IRR squared plus 500 over 1 plus IRR cubed. And so now the game is this. If I put in 13%, is the net present value still positive? Yes, it is. Well, if I put in 14%, yes, it is. I can keep playing this game, and what if I put in K is equal to 30%? Then the net present value is negative. What I'm looking for is an interest rate right here that solves this equation, that makes all this equal to 0. You can't do that by hand. I'll tell you how to solve that later on, but for right now, I'll tell you if you put in the internal rate of return of 23 point, and look at this number, 375%. If you do that, then that means the net present value is equal to 0. So any number less than this that I put in, the net present value is positive. Any number greater than that, the net present value is negative. Let me say that again. Interest rates go down. So if at this rate of 23.375, net present value is 0, if interest rates go down, the net present value goes up, and the net present value would be positive. And the reverse is true. So the IRR rule is this. If the internal rate of return is greater than what I think K is, then I accept. K is my cost of capital. So let me give you a little insight into K. Just pause for a second. K is my cost of capital. So I'm looking at the money the equity holders put in, the money the bondholders put in. Bondholders don't loan me money for free, right? They charge me some interest rate. I don't know, maybe it's something like they charge me 8%. The equity holders don't invest out of charity. They want to get a return on their money. They want to make money. Maybe they need a 15% return. So I see how much I raised in equity from the financing decision, how much I raised in bonds from the financing decision. I combine these two together to say K is equal to something in between there. We say 12%. But we're not really sure what that number is. And we'll talk about that in another chapter. So that's a number I'm not really sure what it is. So I can come down here and I can say if the internal rate of return is greater than K, I accept. So the internal rate of return at 23.375, I don't need to know K precisely, I just need to know K is less than that. If the internal rate of return is less than K, I reject. And if the internal rate of return is equal to K, I don't care. So K is what we call the cost of capital. Very simply, if the return is greater than the cost, we accept. If the return is less than the cost, we reject. Those are the two primary rules that we're going to have. Now, it's possible that these two rules can be in conflict. So I'll tell you the net present value is the king. It's the one that we always go with. Alright, there are two other rules I want to talk about. They're not as important, but you need to know what they are. So let me draw this timeline again. And here at time 0, time 1, time 2, and time 3. Remember, I have to spend $1,000 to get these payments. The rule I want to talk about now is the payback period. I'm going to talk to you about payback period because people use it, but I'm going to tell you why payback period is really, in my opinion, somewhat useless. The payback period is simply how long does it take to get your money back. I spent $1,000, there's 500, there's 500, it took 2 years to get my money back. The flaw with the payback period is that I don't know is 2 years good or bad. It's impossible to tell. Here's the other flaw with payback period. Which project would you rather have? And if you don't get the right answer here, you need to drop out. Would you rather have the blue project or the red project? Would you rather spend $1,000 to get 500 for 3 years, or spend $1,000 to get 500, 500, and $1 million? The answer is, of course, you would take the red project. But the payback period for both of them is 2 years. So I can't really tell you red's better than blue using the payback period. The other thing is it ignores the time value of money. So some people came up with what they call the discounted payback period. The discounted payback period. And it works like this. I have my minus 1,000, and then the 500 divided by 1.12 in the first year, which is equal to 446.43. So this is time 0, this is year 1. In year 2, we have the 500 divided by 1.12 squared, which is equal to 398.60. And in year 3, we have the 500 divided by 1.12 cubed, which is equal to 355.89. So now I'm trying to find the payback period, but not using the 500s, but using the discounted values. So I say, how long does it take to get my $1,000? At year 1, I have 446. At year 2, I have 446 plus the 398. So that is 840. I wrote the number down wrong, so I can do the math here. That's 845.03. So now how much money do I still need? I still need 1,000 minus 845.03. I still need to have $154.97 to get my $1,000 back. So 154.97 over, in year 3 I get 355. I don't really get 355, but that's the present value of it, 89. It's equal to 0.43. So my payback period is 2.43 years. My discounted payback period is 2.43 years. So it works the same. Once again, the payback period, I spent some amount of money. How long does it take me to get that money back? It took 2 years. The discounted payback period, I find the present value of each one of those individual cash flows, and using those, how long does it take those discounted cash flows to add back up to my original expenditure of $1,000. It takes 1 year, 2 years I still don't have it. After 2 years I need a little bit more, so I take that over the part I get in the third year, and that's my discounted payback period. These two rules I recommend you don't use. We only show them to you because people do actually use them, but net present value and internal rate of return are much better.